Hi everyone and welcome back. We are on presentation number 5 and this is part 2 of our study design, and here we're going to be talking about experimental design. Again, take a look at the to-do list. Make sure you're reading the chapters and the articles that are posted in this week's folder, and then we'll have a little bit of an activity at the end of this PowerPoint where you'll be asked to look for a randomized control study and determine the particular type of study design. Take a look at the learning objectives on your own. Experimental design provides structure to help investigate cause and effect relationships. Typically, in an experiment, there is some type of intervention or treatment that is being tested. Clinical trials are used to explore the effect of a particular intervention on a particular population, community, or patient setting. The design of a clinical trial is rigorous and often associated with the testing of new therapies, drugs, or even surgical procedures. Clinical trials include random assignment to intervention or control group, and assignment is often blinded from the researcher. This helps reduce bias and increases the validity of the results. Quasi-experimental design allows for accommodation of the natural environment, and we're going to talk about this type of design in a few slides. These studies often can't meet the rigorous requirements of a clinical trial, and participants are typically not randomly assigned, and therefore you may not have a control group with this type of study. Clinical trials are differentiated by how subjects are assigned. In a randomized design, participants are randomly assigned to a control or intervention group. There may be additional types of groups based on the type of the intervention, but the key is that the participants are randomly assigned to the groups. In a randomized controlled trial, patients are randomized into the treatment or the controlled group. Follow-up occurs, and then the results between the two groups are compared and reported. This design increases the chances that the differences between the two groups is attributed to the treatment. There are different types, I should say, of randomized studies. In parallel design, different patients are randomized to either the treatment or control group. Another type of design is the pre-test, post-test control group design. Here, two or more groups are randomly assigned. One group receives the intervention. The second group does not receive the intervention. It's the control group, or perhaps it's a placebo group. All groups receive a pre-test and a post-test, and then testing is to see if the intervention has an impact on the changes in the pre- and post-test results. Typically, a hypothesis might be that the intervention group will score better at the post-test than the control group. Another type of design is a post-test only design. This is identical to the pre-test post-test, except that only testing occurs at the post period. So this is typically after the intervention takes place. Because you're still using random assignment and a comparison group, the study design is still strong even without a pretest. In a crossover study, participants are randomized to treatment A or treatment B, and then crossover to the other treatment at the completion of the first treatment. In this way, the participants get both types of treatment, but it is the order of the treatment that is randomized. A major assumption here is that the treatment in the first period will not carry over to the treatment in the second period. In a cluster design, groups of subjects are randomized rather than individuals. Randomization is at the group level versus the individual level. For example, students may be randomized based on school or classes rather than on individual students. Cluster design can be utilized in any type of randomized control design, for example, crossover, parallel, or any other type of study. Factorial design incorporates two or more independent variables with independent groups of subjects randomly assigned to various combinations of levels of the two variables. This is an example from the book. A and B represent independent variables. A equals exercise intensity, and B equals the location of the exercise. Here, the researchers were interested in examining the effect of intensity and location of exercise program on the self-efficacy of sedentary women. The number of groups in a factorial design is determined by the number of variables and levels that define the study. For example, here we have two variables with two levels. This equals 4 groups. If we had 60 patients, we would randomly assign 15 to each group. Factorial design allows researchers to see the effects of multiple conditions or factors on a dependent variable, the outcome. What is a repeated measure design, and what does this really mean? It simply means that a participant is administered a treatment or intervention at a specific time, and measurements or tests are also administered after each treatment or intervention. Because participants are receiving the same repeated measures in the same fashion, there is potential for bias, or simply the repeated testing may lead to fatigue or influence responses. The participants basically learn how to answer the questions either knowingly or unknowingly. A way to help to control or minimize these impacts is offering the treatments in random order or randomizing the patients to the treatment. Crossover designs are another option to use with repeated measures. Here, participants are randomized into groups, complete one of the programs or treatments, and then cross over to the other program or treatment. Again, this allows researchers to look at the sequencing of the events. And one thing to keep in mind when using this type of design, what we call is a washout period, is important. This helps eliminate or minimize the effects of one treatment before starting another treatment. So a period of time is waited in between each of the treatments. Two-way repeated measures are typically used when there is more than one independent variable. Let's take a look at an example. Say we wanted to examine the impact of increased and decreased time watching TV and increased or decreased access to junk food on the amount of junk food consumed. Both time watching TV and access to junk food are the independent variables, and the dependent variable is the amount of junk food consumed. Unlike the factorial design, where participants are randomized to groups, in a repeated measure, participants go through each of the repeated measures, sometimes in a random order. So each person would experience each of the intersections of the variables. As I had mentioned earlier, quasi-experimental design is yet another type of experimental design. Here, there's one group that goes through a pre-test and a post-test. There's no control group. All are tested or given a pre-assessment, then receive the intervention, and then receive a post-assessment. Here, everyone is receiving the intervention, and everyone is tested prior to and after. Some of my dissertation work used this design method. I was looking at the impact of a food literacy focused intervention on changes in food literacy knowledge. Participants took a pre and a post food literacy questionnaire before and after the intervention. There are other examples of quasi-experimental designs, including time series, which includes multiple measurements, more than just a pre and post test. Here, there may be a follow-up test after the post test, or different portions of the interventions are administered at different times, and there are multiple post tests after each intervention element. What is important for these types of study is that a pre-assessment, a baseline, is established prior to testing. For example, if a study is looking at the change in weight of participants enrolled in an intervention designed to decrease waste, then prior to the start of the study, a baseline assessment would need to be obtained, and you would need to get participants' weight and any other anthropometric measurements at that point. So the key here is there are repeated assessments of outcomes under study. There's a pre-assessment, then the intervention, and then the post-assessment. Effectiveness is not a logical conclusion based on the efficacy of a study. However, studies are often presented in this way. You may have heard the saying, what looks good on paper doesn't necessarily work in real life. This is a super simplified way to think about the difference between efficacy and effectiveness. Efficacy is what works on paper. Effectiveness is the ability to translate that work on paper to a real-life application. Your book has a table on page 219 that indicates the criterion for determining and distinguishing the difference between efficacy and effectiveness, so be sure to take a look at that. So how can we determine cause and effect? To determine cause and effect, we're really looking for three criterion. The first is temporal precedence. We must be able to show that the exposure came before the outcome. We must be able to show that time sequence of events. The next would be covariation of the cause and effect. Here, we have to be able to show that there is a relationship between the variables before we can show that there is some type of cause and effect. So how can we do this? Well, an easy way is to determine if there is a relationship is to determine when the exposure occurs, does the outcome occur? So when the exposure occurs, does the outcome occur? And when the exposure does not occur, does the outcome not occur? The exploratory studies that we discussed in part 1 can really help with this, sort of establishing that potential link or that association between them. The third criterion is no plausible alternative explanations exist. We need to be able to determine that there is no missing or alternative variable that could explain the cause and effect. This goes to the internal validity of the research design, and we need to be able to rule out any plausible alternative explanations. For this activity, find a randomized control study for a topic related to your research. Identify the study design, and based on what you now know, how would you classify the study? For example, is it a pre-post test design, a parallel design, quasi-experimental? This is where I'm going to end the presentation. Be sure to read the chapters and complete any assignments and activities due this week. Again, as always, if you have any questions about anything, don't hesitate to reach out to me as soon as possible. Have a great day.